128 cores, 192 cores. In this form factor, AMD has left us behind. They've forgotten us. Zen 5 in this form factor. No, they haven't. These are AMD EPYC in an AM5 form factor. This is a Zen 5 refresh. This isn't the first time that AMD has done this. This is the second time. But I've got the new version of the MC13 board from Gigabyte. And we're going to take a look because EPYC in this form factor, 16 cores, 128 gigs of memory, 192 gigs of memory, 256 gigabytes of memory. In this form factor, in a server qualified platform, yeah, AMD can do it. It makes sense if you think about it. If you do anything with home lab, you know how much you can get done with 6, 8, 16 cores. And the full lineup here includes a whole bunch of CPUs from 6 to 16 cores, including one with V-cache on one of the CCDs. 8 of the cores have V-cache, the other 8 don't. So it's basically a mirror image of the desktop counterparts, but it wouldn't be fair to call that a rebadging of the desktop counterparts for some specific technical reasons that we'll talk about. The bottom line is that you can get a lot done with a relatively small number of cores. Windows Server 2025 starts at licensing 16 physical cores, and you can run 2 VMs with that. So Microsoft certainly thinks that you can get a lot of mileage out of a 16-core platform with virtual machines and everything else like that running underneath it. And the reality is that, yeah, if you have a 50-person or 100-person file share that you need Windows to run, or a print server that you need to be physical hardware or something like that, something like this platform will make sense. If you're running 192 cores, yeah, can you pack on like 40, 50 virtual machines or para-virtualized containers with 192 cores? You absolutely can do that. But then the blast radius, if this goes down, that's taking out a lot of machines with it. There's also power factors and power constraints. So in the European Union, it's very difficult to run a data center that has machines in it that are consuming 500 to 1,000 watts per socket with air cooling because of the worker requirements. Like, it's going to be so noisy in there, even with earplugs, it's a little bit challenging. That kind of power density in Europe is also a little bit challenging. And so data centers that have existed since the late 1980s, 1990s, and early 2000s, where they were designed to support, 10,000 watts per rack, really have a hard time deploying anything except a solution like this, because this is relatively low density and fits within the power requirements of what existed previously. Also, physical servers like a local file server or a local email server or something at edge compute for like small and even medium-sized businesses, this solution makes a lot of sense because it's not very expensive, but you get a lot of compute horsepower and you get a lot of flexibility and upgradability. And the cost is definitely a factor there because this is a less complicated solution. It is also going to cost less. And yeah, it does top out at 16 cores, but again, 16 cores gets the job done. And it is an interesting dynamic in terms of building new data centers versus trying to refurbish old data centers. A lot of the major providers, the cloud providers like OVH and Hetzner and MevSpace and Scaleway, and those companies can deploy this kind of solution in their old space, and people still want to buy these kinds of machines. There are a lot of sysadmins out there that prefer a physical bare metal solution like this, where you can do out-of-band management and get direct out-of-band management on your hardware, and you can just run whatever you want. And yeah, that's a thing that some administrators look for in the cloud versus, say, a large VPN instance. And if you do the math, a lot of the time, having this kind of physical bare metal hardware is often less expensive, even in the long run, than hosting a virtual machine that has similar capabilities. There's some trade-offs there because sometimes the virtualized component can have better performance than this, but it's like a bursting thing or there's performance counters, and so that's not always universally true. But a lot of the time it is true. If we look at the layout of these EPYC 4005 CPUs, you might notice, well, it looks a lot like Zen 5. The Zen 4 to Zen 5 EPYC upgrade, AVX 512, 28 PCIe Gen 5 lanes, which is an interesting situation on this board we'll take a look at. And yeah, basically it's Zen 5, but it's Zen 5 with more qualification. It's not that they just rebadged the chip, it's that they also went through all of the qualification steps to say, hey, this will work with a RAID controller, like an LSI hardware RAID controller for physical spinning Rust type disks. RAID, as far as like modern NVMe goes, is not really a thing anymore, at least hardware RAID. It's all pretty much software RAID on the NVMe side of things for large storage pools. You get it up into things like Weka and Pure Storage and those kinds of solutions because hardware just can't keep up with that. But this platform has 4 SATA ports, and it has some pretty awesome NVMe expansion capabilities. And this board has an MCIO connector as well. So you get the X16 slot plus an X8 MCIO and some switches redrivers there to deal with that situation. But again, we'll get to the board in a second. This is a fully qualified AMD Trust Zone security solution, TPM 2.0, and it also supports SME, secure memory encryption. On the AM5 socket, yeah, that's what AMD says. SME. The other big upgrade with this platform is DDR5 5600 supported natively. That's when you're using a 2DIMM configuration, and that is not a weird double-speak version of 2DIMM. On this board that has 4 sockets, I can run 2 DIMMs at 5600. That is explicitly part of the AMD spec. We aren't playing shenanigans or games or anything with that memory spec the way that you have on other platforms. That is, however, an ECC UDIMM, unregistered error-correcting DIMM. And that is not as easy to get a hold of as registered error-correcting DIMMs. Maybe it might have been cool to bifurcate but then qualification and it sort of opens up a Pandora's box of other things. But ECC UDIMMs. I can get my hands on some 48 gig ECC UDIMMs. I've got some 64 gig non-ECC UDIMMs. We're going to try this in just a minute. But 48 gigs ECC, 192 gigs of ECC memory. Sounds good. RAS daemon, full plumbing to the IPMI, and full qualification. This also benefits AM5 desktop boards because AM5 desktop boards, such as those that I reviewed from a lot of different companies, often I will call out the level of bakedness of ECC support. And so a lot of the time on the desktop boards, it's like, well, maybe it has ECC or the ECC soft disabled, or some of the plumbing for ECC isn't there, or maybe the trace layouts and routing isn't there for ECC. But there are some desktop boards that have ECC support. And right before Zen 4 EPYC launched, a lot of the loose ends that I was complaining about on desktop boards for ECC went away. And because this platform exists and because it has a lot of customers, we also enjoy the benefit of ECC UDIMMs on Zen 5 for the board partners that qualify that and set that up. Of course, everybody that is doing a server class motherboard, like Gigabyte, they're fully baking that and fully qualifying that, and they're on the hook if something doesn't work. And they also, I have their phone number. I will hunt them down. And you can also complain in the forum and let me know what you found, and I will try to deal with that. Now let's talk pricing and stack. These CPUs cost up to $700, $699 in the 1,000 unit tray price. So $700 gets you 16 cores and Vcache. They're actually launching 6 CPUs for this stack, up to 5.7 gigahertz, and with up to 128 gigabytes of L3. That's one chiplet with 32 gigs and one chiplet with 96 gigs. There are 3 SKUs, 6, 8, and 12 core. That makes sense. But then there are 3 16 core CPUs. And again, this is popular because cloud providers and the people buying these systems in volume are looking to just go ahead and buy 16 cores. You can get 16 cores in a 65 watt, a relatively low power configuration. You can also get 16 cores in a 170 watt, and you can get 16 cores with Vcache. That is awesome. That basically covers all the use cases that you'll run into in the cloud, in the enterprise. And I would just say that if you're looking for a standalone server, file server, something like that, the 12 or the 16 core part at 170 watts makes a lot of sense. The 65 core part, I mean, maybe for an outdoor edge compute kind of thing, maybe. Just go ahead and get the 170 watt part, and that's really like, that's a good all-rounder for this platform. The cost difference is negligible. I mean, what we're talking about here is really $40 to $44 per core. So, yeah, why wouldn't you just get 16 cores to begin with? Does that also mean the 6-core part is $240? Well, I mean, it doesn't, not necessarily. 6 times 5 would be $300. As part of their presentation, AMD also called out RAID Expert 2 for server. I'm going to go ahead and tell you that RAID Expert 2 for server, on the Linux side of things, Linux MD is what you want to use for RAID. I'm going to try RAID Expert 2 for server on Windows Server 2025 and see how that goes. That's going to be a lot of fun. But first, let's talk about Gigabyte and this PCIe Gen 5x16 motherboard, which is going to be my wonderful chariot for testing and doing stuff with these CPUs and different memory configurations. So first up, the layout. Now this should clue you in a little bit to how overbuilt modern desktop boards are. This is all the VRM that you need to deliver maximum power to a 16-core CPU. Now with overclocking, okay, you might need a little bit more, but you won't need ridiculously more. These boards are also designed for more front-to-back airflow, which is part of why the socket has been rotated. It's designed for a different kind of cooler. It still comes with the standard AM5 mounting solution, but if you're looking to, home lab or DIY one of these things, just pay attention that the socket is rotated. That can be a problem for tower coolers. You may want to use an AIO or something like that for your cooling solution. The other important reason is the DIMM orientation. See, DIMMs can use a lot of power, DDR5, and registered error correcting DDR5 uses the most power, which is not on this platform. This is unregistered error correcting. So it doesn't use as much power, but it's still better for airflow and cooling for the DIMMs, for that front to back airflow for the DIMMs to be oriented this way. We have our standard 8-pin CPU power input at the top, standard ATX 24-pin. We also have the system management bus header, which is useful for connecting to power supplies and everything else, because there is a whole system management bus that will plug into the out-of-band management, which is powered by an ASpeed 2600. That's why the built-in VGA connection that's provided by the ASpeed interface it's a computer within a computer. Basically, this thing has its own RAM, and it's a full standalone computer that runs Linux and OpenBMC, and you can do a lot of fun things with that. This particular board also has built-in dual 25 gigabit that is powered by the Broadcom BCM 5702, which is great. It also has dual 1 gig and then a dedicated out-of-band management. We've also got two 5 gigabit USB ports at the front. And for other USB connectivity, we have another 20-pin header for 2 more Type A ports. You could put that at the front or the rear, whatever particular configuration your chassis is going to have. We have a PCIe 5x16 slot, which can be split into X8 and X8 into our MCIO connection. We have a Gen 5 M.2, and then we have 4 PCI Express 4.0 lanes through another slot at the bottom. With more USB ports, this would be my fantasy workstation board. I mean, why don't we have Threadripper boards that have built-in 25 gigabit at this point? 25 gigabit fiber optic is less expensive than 10 gigabit in a lot of cases at this point, because 25 gigabit has been around forever. And this is dual 25 gig, 2x 25 gig. We also have RS-232 serial at the back, which some people use for connecting to low-speed devices, sometimes an uninterruptible power supply, things like that. This can also be used for a serial console with BIOS configuration. We've got 4 6 gigabit per second SATA ports at the front as well, and there is a USB 2 header. We have a total of 7 4-pin fan headers for cooling. All right, let's get this thing built. So as we get this thing set up on our test bench here, you might be wondering, what's this MCIO thing? If you follow our videos for a while, I've probably explained it before, but MCIO is really awesome. MCIO is the non-jank version of providing flexible ways to use PCIe lanes without taking up as much room as a PCIe slot. And believe it or not, the PCIe slot design, even modern redesigns of the PCIe slot, there's a lot of loss there in terms of signal to noise. Like it's a physical big honking non-modern connector, really. I mean, yeah, we've done Herculean things. I say we, but the engineers, I had nothing to do with that. Herculean engineering in order to make Gen 5 signaling work through a slot like that. But the bottom line is the MCIO connector is much more modern, much more resilient, and much better in terms of being able to deal with high-speed signaling, even up through PCIe Gen 6. So that's not official. It just looks like it's going to work for Gen 6. Unofficially is what the word on the street is for that connector whenever Gen 6 is rolled out on platforms. So you've got 8 lanes that'll be available in the PCIe slot, well, up to 16 lanes. And then the other 8 lanes for this connector. Now this connector could route to a PCB that gives you a PCIe slot. It could route to 2 U.2 drives. We've covered that before, like in my 45 drives home lab build video, if you want to check that out. I use the MCIO headers on the motherboard to go to 2 U.2 devices. You can do E1 devices, those are all PCIe lanes. At the end of the day, basically everything is PCIe lanes. And this is also why a lot of the times people are interested in what the bifurcation support is on these PCIe slots. Can this X16 go to 4 X4 slots? Can it be X8, X4, X4? You don't always have all those combinations on motherboards because you can kind of try to take matters into your own hands and DIY it with a PCIe slot adapter. But sometimes that's fraught with errors, or you can introduce PCIe errors, or it won't work at Gen 5 speeds, it'll only work at Gen 4 speeds. MCIO is a connector that aims to change all of that, and it's already taken root in servers, higher end servers, and so it's very nice to see it come down to the AM5 platform. Heck, this is something we even covered when we covered Threadripper motherboards. Like, what Threadripper motherboards out there have MCIO connectors? A few of them do, but not all of them. And this is a much more reliable connector than older slim SAS style connections, which are really just repurposed. Those are the only connectors available on the market that could deal with kind of high-speed signals. They weren't designed for PCIe signals. They were designed for serial attached SCSI signals. They just happened to work for PCIe. So it was a bit of a mess. MCIO is sort of righting all of those wrongs of past, and having an 8-lane MCIO connector on an AM5 platform is fantastic. PCIe Gen 5 routing on this platform is your Broadcom NIC plus your chipset plus 16 lanes plus 4 lanes for your M.2, and then from the chipset you have your PCIe Gen 4, and then you get your choice of 8 lanes, 8 plus 8 into the X16 slot, or 8 lanes to the MCIO connector and 8 lanes to the PCIe connector, which is a pretty reasonable setup in my opinion. These are also useful for cloud gaming servers. Like, there are people out there that run Steam on a remote machine with a GPU, and then they just use that as their cloud gaming box. And so your cloud host provider can maintain a fleet of these, and then when you need to run a Steam game or something like that, it's got a full, 3080, 4080, 5080 GPU in the platform, and you're just doing like Steam in-home streaming, but it's Steam in-home streaming over the internet. Or maybe you're using one of the other Steam streaming, the desktop streaming solutions out there. There's a bunch of different software that's low latency, high fidelity streaming. Basically, you're building your own Google Stadia, because Google Stadia is not a thing anymore. All right, we got this platform. Oh, RAM. Let's talk about RAM. All right, our first kit of memory we're going to test is from SK Hynix. And it's the cheap stuff. It's only 4,800. Oh, we're going to need a monitor. Let's look at the BIOS in 5K. Their Asus 5K monitor. I did a review on this. You should check out that video. What other channel is going to bring you the BIOS in 5K? And you might be thinking, it doesn't have VGA. Yeah, it's fine. VGA to HDMI adapter. Hey, we're booting. That's nice. That's what I like to hear. Gigabyte really gives you the beep codes to let you know what's going on, even if you don't have a display. I missed it, I think. So, SK Hynix, pretty good, but it did take 5 minutes for training. Let's try Crucial next. And here's our setup with 256 gigabytes of memory. That's right, 256 gigabytes. And this platform was the easiest to boot with 256 gigs of memory of any AM5 platform. But, and I suspect this is the reason why, the memory is going to run a DDR5 3600. That's what it trained at, and that's with BIOS R08 on our MC13 gigabyte board. Now the timings and everything else is perfectly reasonable at DDR5 3600. The thing to keep in mind is, as the memory density increases, so increases the latency. 96 gigabytes, 48 gig DIMMs is still pretty much the sweet spot. 64 gig DIMMs are brand new on the scene, and the CAS latency of our Crucial kit here is CL46. So it's quite a bit worse than your best case scenario of CL28, CL30 for your 32 and 48 gig DIMMs. There's a lot of different factors that can affect memory speed overall, but still, 4 DIMMs, 2 DIMMs per channel, 256 gigabytes. There's a lot of people out there that really don't care about the speed of the memory. Well, I mean, they care a little bit, but 3600 is perfectly serviceable when you have 256 gigabytes of memory. And 256 gigabytes of memory, plus our dual 25 gig interface, plus I still have 20 Gen 5 PCIe lanes free. That's pretty awesome. Now this platform, you might remember, 28 PCIe Gen 5 lanes, but 8 of those lanes are hardwired for Gen 4. 4 lanes of Gen 4 to the chipset, and also our Broadcom interface, believe it or not, is also PCIe Gen 4 by 4. 8 gigabytes per second, but that makes sense because it's 50 gigabit. You're going to be able to move at about 5 gigabytes per second. You got plenty of room to work with in terms of bandwidth, and you save a little power that can go somewhere else inside the CPU. Now the BIOS tour is interesting. Pay attention as we go through the options here. It's your standard issue server BIOS, but notice there's no AMD CBS or PBS menu on this board configuration. I don't know if this is part of a larger trend. A suggestion is AMD's ecosystem with AM5 matures, or if that's just something for this particular board from Gigabyte. To Gigabyte's credit, they do expose a lot of the options that you would need from the CBS and PBS menu, including being able to set your PPS, including being able to set resize bar, SR-IOV, and other options. But still, they don't expose every option from the AMD CBS and PBS menu. I was also pretty excited to see that this thing supports iSCSI boot, full EFI support for all of the NetBoot, HTTP boot type options that you would get from both the Broadcom and the built-in Intel NIC. Further, this thing has the NCSI header, so if you wanted to add you know, like a Bluefield adapter or another third-party adapter and share out-of-band management on the NIC, there's a header for that. As it is, there is a built-in switch in the BIOS that'll let you configure if you want out-of-band management to be shared with the onboard 1 gig Intel NICs or the Broadcom 25 gig NICs. That's right, you can do out-of-band management on a VLAN on the Broadcom 25 gig NICs with just a software setting, or even an external, another external NIC with the NCSI header, but that does require a jumper change. So bottom line, these two 16-core parts perform like their Zen 5 desktop counterparts. The difference here is that the platform and the CPU in this combination with error correcting memory, both Gigabyte and AMD have spent significant time qualifying this solution for use in a server context with server software, not just Linux, but also Windows Server 2025. And they've also put more work into tweaks and fixes and stuff for the platform, which to some extent, as I was saying before, will carry over to desktop, but some of them are going to live exclusively on the EPYC CPUs, which is awesome. So today with the launch, it's another notch of advancement for AMD, don't get me wrong, but also AMD has become a boring execution machine, and I mean that as the highest possible praise. Customers don't have any surprises buying with this platform, and they can expect a higher level of support. Incrementally more support with every generation as AMD gets market share, learns lessons with customers, and so on and so forth. So yeah, Zen 5 on the AM5 platform. Could you use one of these as a desktop? You could, but mostly this is for data center, workstation, and people that are running server class operating systems. If you want to see me do a particular test with this, or there's a benchmark that I need to do or something like that, hit me up in the forum. I would love to hear from you. And I would love to hear from you and, you know, show pictures and that kind of thing. If you've got a solution like this that you've already deployed on Zen 4, what are your thoughts on Zen 5? I'd love to hear from you on the forum. I'm Wendell, this is Level 1. I'm signing out, and I'll see you on the Level 1 forums. Zen 5! 5x5, because it's AM5 and Zen 5. Woo!